Hi, in this video we're going to be going over removing the Syncfusion dependencies from the automation designer. So what we're going to do is we're going to end up replacing it all with WPF controls. So main reason we're going to use WPF is it can be easily styled and customized to make it look nice. There's not a lot of great options like that from Windows Forms. I'm pretty, I feel pretty comfortable with WPF. I was kind of hesitant to use WPF in this project just for making it simple for people to get into. We'll go and test it out like this and see how it goes. Um, so I'm going to walk you through what I've done on the Inventor capture panel, and then we're just going to create the SolidWorks one and just recreate it for SolidWorks. So what we did is we went and created a user control that duplicates the Windows form that did the dimension capture. Um, so you see we're importing styles from a library called MaApps. So MaApps is a open source WPF styling kit to make things appear more metro, kind of like the newer Windows format. Um, then everything's hosted inside of a dock panel. A dock panel is kind of an interesting one. It's kind of like a stack panel that we can control where things are laid out a bit better. One thing it does really nice that I like is that it doesn't let things go to infinite sizes. It makes certain things fit in the window. So that does make our life a bit easier there. And then we have a grid that has the buttons in it. So, and we have a loading indicator running. So that's a kind of improvement from the old app, and we're using WPF now, and so we're going to be using MVVM. So we'll make some of the asynchronous tasks easier. And we've got everything hosted inside of a tab control that looks pretty similar to what we had. The only thing missing right now is the filtering. I think in a later video we'll go through recreating the filtering control. You know, if anything, it might be a fun WPF video. I know it's not really something I normally do tutorials on, but it might be an interesting endeavor. Um, so, and if you're not familiar with WPF or in MVVM, I'll go over that too as we start creating the SolidWorks one, and I'll kind of explain it here a little bit too. So, we're binding to commands in the ViewModel. So, in our ViewModel bindings, actually, back in the code, you'll see that we have our ViewModel. So, it's the Inventor Capture Design ViewModel, and then our data context. Let's go look at that ViewModel. So it's just a normal C# class, except it's inheriting base ViewModel, which is a class I created, which does a couple things for us. It implements iNotify and takes care of all the handling for us, all the property handling for us. So when things change, it knows when to register. And then it has a built-in async command for telling things to let us run asynchronous tasks and then update a flag. Um, okay, so what I want to go and do on this video is go and finish up the spinner and get it running. So we're going to actually create a value converter real quick. So let's go and get started on that. So if you're not familiar with what a value converter is, so a value converter allows us to convert from XAML based selectors over to basic C# ones without us having to actually import XAML controls into our view model. Now, it would be perfectly valid not to do that and just import the XAML control into your view model. It's not really how most teams like to write MVVM. It's usually not the recommended way to run MVVM. My personal, I guess, philosophy on it is if you can do it in MVVM, go ahead and do it that way. If it ends up being a pain, and there are some times with MVVM where it's just a nightmare trying to make it work, just import the control directly. I mean, in my experience, it's just so unlikely to actually port an application to another function without huge rewrites anyway. So I wouldn't lose any sleep over that. So let's go ahead and start getting this value converter written. Okay. So what we're going to start is we're just going to create a folder called value converters. Okay, and now we're going to add a base class for our value converters. So we're going to say base value converter. Okay, we're going to change this over to public. And we're going to make an abstract class. Now, if you're not familiar with an abstract class, all that means is that it can work like a base class and an interface. So it can have methods that function how an interface does. If you're not familiar with what an interface is, I will go over them real quick when we go back over the ViewModel, just so you have an understanding of what they do. If you're not familiar, if you're really not familiar with interfaces, it might be good to take a C# kind of basics class or training, because it will make your life easier understanding what those do. Because in modern C# programming, they're pretty common, and even in modern TypeScript programming, if you're on the Node or even on the Angular or React side. Not that you would necessarily always see TypeScript on React. It's becoming more common. Okay, and now we're gonna. So this is an example of implementing interface, and you can see it's upset that we haven't implemented members for it. And I'll show you an example of an interface I created for the app too, where it won't be happy that we haven't implemented methods. So basically, what interfaces allow us to do, which is the most useful thing, is they ensure common functionality between objects. So especially in collections, they can be super useful. Like if you have some generic functionality that you need passed between objects in a collection, but you don't really care about how they implement it, as long as they implement that method, it allows you to make these super generic collections that aren't bound to each other. All right, so now that we've got everything kind of going, so let's go ahead and make some methods. Oh, and I guess let's explain a little bit, because we have some generics going on too. So we're implementing a generic of T. So it allows us to implement anything that's a class and can be new. So these are the constraints on the generic condition. So we're just saying T has to be a class, and it has to have a constructor, a parameterless constructor to be specific. All right, and now we're going to actually change these over to abstract methods now. Then we won't implement these right now. So this is and what will happen now is our methods that are classes that actually inherit. No, I actually don't remember the exact term if when you inherit I do believe it's still inherit from an abstract class versus implement. I'm not sure the terminology exactly. All right. Okay, so now that we have that done, we're going to go and create. Now we're going to create one specifically for visibility. That'll be a pretty common one for various turning things off and then for our loading indicator. So let's go and create one. So we're going to call this one Boolean to visibility converter, not controller. Oh, come on, Visual Studio, let's finish this up. By pausing on Visual Studio, apparently. All right, resuming. Okay, add class. So we're going to add a class called Boolean 2. Okay. All right, so let's go and create this now. So we're going to make this again public, and then we're going to implement our abstract class. Okay. And now we have a tool that will actually convert that will actually convert Boolean values over to visibility parameters. Not that you just couldn't do that in your view model, just I think it makes it a little bit more convenient just to do it that way. Okay, so now we got our Xaml pulled back up. Let's go ahead and grab our view model. So now in our Xaml, so what we need to do is we're going to create another view field, and we're going to call this one private bool loading. Okay, and now we're going to create a new property, say public bool loading. Okay, so now that's created. So now let's go into this guy. So what we're going to do is say visibility, and we're going to say binding, and we're going to say loading. And we're going to say, I think the next step is, okay, now we're going to say, so now we need to get a reference to our value converters. So we're going to say XML, so this is going to be our XAML namespace. We're going to say converters, and we're going to go to CLR namespace, automation designer dot value converters. Okay, so now we'll be able to reference that. So now we're going to come into our button now. We're going to say this is going to be, all right, so then that should be it. And then we're going to go and pass it a converter parameter of true. Okay, let's go into a build real quick. Okay, now we should be good to go. All right. Let's take a look at that now. So now when we go look at that, all right, see, it's not showing now. So now what we're going to do is we're going to do a little bit of async work. So what we're going to do is we're going to, so the capture design command, we're going to switch it over to run asynchronous. So we're going to actually change capture dims to a task. So we're going to say async task capture dims, and then we're going to go we'll just go and start everything here. We'll go and say await task dot run. Okay, now we're going to grab everything that we have that runs inside this method, and he's just going to they're just all going to go inside of this. Okay, and now we got to go one more. We're going to go await. So now that we're in there, we're going to say run command, and we're going to say Loading. I just think it's just loading. No. I think we can actually just remove this now. Okay, so let's grab this guy. Okay, let's go and add our. Oh, just a second. Need to do a little bit more work since we're doing this as a function. So what we're gonna do now is we're gonna go and say okay. Now we'll bring this code up. Okay, now we're good to go. Always kind of forget a couple of these steps if I haven't done this in a little bit. Alright, so what a run command does is he'll constantly keep an eye. So he'll go and set loading to true when he's running, and then he'll go and run our task, and then he'll also keep everything in a final statement. So one thing we also should do on our end is we want to make sure that we're gonna catch this if we have any errors. So we're gonna go and bring our task in. Okay, now we're gonna catch. Alright, and now, for now, we'll just say debug. For now, we'll just throw the exception. Later, we'll implement some actual logging to let the user know what's going on if there's an error. Okay, let's go and see how that looks now. Okay, let's view our. So it's clean. Okay, so let's go and see what we have going on. Oh, okay. Okay, so we're going to switch that over. It'll be better to handle it that way anyway, just because it's a long running one. So now we need to tell our command that it's running asynchronous. So we're going to say await. All right, and now our task can run asynchronous. Now our command can run asynchronous commands. All right, so let's go and run that now. Okay, so we will deal with this error next because we're now that we're adding features from multiple threads, we're going to run into an issue here. Okay, so let's take a quick break and we'll go through what we need to do to make that work.